So I'm going to be talking about how our body digests food, the different macronutrients, where they all go in the body, kind of the whole storage process, all of that. So when we begin the digestive process, we actually start digesting food before it even hits our mouth. When we see or smell something that looks really appetizing, our mouth starts producing salivary amylase. So our saliva actually starts secreting this chemical, this acid, to start to break down carbohydrate. Our stomach will start producing other acids to break down food and it kind of starts waking it up. So, like, especially if you're getting kind of that stomach gurgling, that's kind of what's happening. It's preparing to eat. So then when we do put food in our mouth, we start with the salivary amylase starting to break down our carbohydrates, and we start with mechanical digestion by chewing. So we're chewing, we're breaking the food up into smaller pieces. And when we get it, pretty well chewed up, we create what's called a bolus of food. So blob of our food and saliva, and we push it to the back of the throat and we swallow. So now we swallow, it goes down through the esophagus. Nothing really happens in regards to digestion in the esophagus. It's just a tube that is moving food down into the stomach. What is something we want to note, though, is there's something called peristalsis happening in our esophagus, which is basically the muscles are pushing it down into the stomach, and there is a sphincter, an opening between the esophagus and the stomach, and it's closed when we're not eating. And when we need to put food or fluid down into the stomach, it opens up so the food and fluid can go down, and then it should close up again. Something to note that can cause problems if someone has a loose lower esophageal sphincter, or they are vomiting a lot, like in bulimia, this can get loosened up and then the sphincter doesn't fully close down, and it causes stomach acid to be released more easily. That can cause acid reflux and damage to the esophagus. So it's definitely something you want to get checked out by a doctor if that's happening. But general healthy human, this sphincter is closing. Okay, so food gets into the stomach, down through that sphincter into our stomach. Our stomach is a really cool organ, often called the second brain. Our gut is like our second brain because there's a lot of communication happening between our gut and our brain and telling us things like if we're getting full, if we're still hungry, what we need. There's a lot happening there that I'm not going to go into in this video. So our stomach also has the volume capacity to hold anywhere from about a tablespoon of food and fluid up to a liter of food and fluid. And that's quite a range of how much our stomach can get stretched out. And where it's hanging out on a day-to-day basis, usually it's not the smallest or the largest. It'll hang out somewhere in between, and that's going to be consistent with what our typical meal size is. So how much food and fluid are, in terms of volume, are we putting in on a consistent basis? And that's kind of how big the stomach is just hanging out, right? So we eat, food and fluid come in here. We have our stomach acids and gastric juices that are in there, again, chemically breaking apart the food into smaller molecules, as well as the physical churning of the stomach. So your stomach, the muscles of the stomach are moving the food around and also helping to break it up. So all of that's happening in the stomach, and we're getting it down into smaller molecules. So usually single or double molecules of our different food ingredients. In terms of the chemical breakdown, there are different acids and enzymes that our body produces that break down the specific types of food that we're eating. So in terms of macro and micronutrients, different things are helping break those specific things down. Okay, moving along into the small intestine. So we go through another sphincter at the bottom of the stomach into our small intestine. I should also note that the timing of when our stomach releases food into our small intestine also matters based on how much we're typically eating. So it's not like we're just kind of dripping food into our small intestine at all times. No, it gets a certain amount and it creates pressure on the lower part of the stomach, which allows the opening of that sphincter for the food and fluid to go down into the small intestine. So when people are having like a delayed transit time in their gut, that can be something that's getting delayed, is like the stomach is has like, it's called slow gastric emptying or delayed gastric emptying. And that's where it's literally too slow coming. Like that, usually it's because there's not enough food being consumed, such as in the case of restriction, so that the stomach doesn't get enough pressure to like open up and let it through. So then the next part isn't happening yet. And so also a little bit of our food gets absorbed through our stomach. So we're getting the usefulness of those molecules absorbed through the lining of the stomach wall. Most of it does not, however. So the majority of it is going to get absorbed into our bloodstream in the first part of the small intestine. So our small intestine has 3 segments to it, and I believe this is the correct order, but don't hold me to it: the duodenum, the ileum, and the jejunum. Again, I'm not 100% sure that's the correct order, so I'm just going to say small intestine for the purpose of this. But the first part of the small intestine, we are getting some absorption of nutrients directly through the cell walls of the small intestine and into the bloodstream. This is literally how we take the energy from food now in these single molecules and bring it into our bloodstream, which is our highway of moving nutrients around and dropping them off where they need to go. I'll finish talking about that in just a bit. We also have the gallbladder, which produces bile and bile salts, which is getting dripped into our small intestine at this upper part. And bile helps emulsify and break down fats so that they are in their smallest molecule form to go into the bloodstream as well. So that's why our gallbladder and bile and all of that is so important, because it's helping us literally digest fat. So then our food, again, so most of it's getting absorbed into the bloodstream. I'm going to talk about where it all goes in just a moment, but I want to finish the digestive tract. So anything that is not absorbable, basically, which is fiber. Fiber is what we would consider non-nutritive. It's non-caloric. It's stuff that's going to get bypassed. That's going to keep getting pushed down through the intestines. And when it gets to the large intestine or colon, the purpose of the large intestine is to essentially dry out what's left. So our body at that point is absorbing any water from the food matter that's left. And so it's drying it out, and that's essentially what is going to create our feces, because that's going to be a lot drier and denser, and it's primarily fiber and any other non-digestible stuffs in our food, things that are harder to digest. That's all going to end up in that process. Also in the last part of our small intestine and in our colon is where we're having a lot of bacteria fermenting things. We do want this good bacteria in there. There, of course, is potential for growth of bacteria that we don't want, or overgrowth of bacteria. But in our general healthy gut, we have our healthy bacteria. This is why we want our probiotics and prebiotics that are doing beneficial things, essentially, because of the large intestine. And then we would be eliminating the waste in a bowel movement. Okay, so that's what's happening in the digestive tract. So now let's go back to all of those beneficial food molecules have been absorbed into our bloodstream. So this is where the nutrition actually kicks in and is being useful to our body. So let's talk about where that stuff goes. So these molecules are being transported through our bloodstream and getting dropped off first at any cells in our body that immediately need those molecules. And Sorry, my dog is trying to come up on my lap here. She might be joining us. Come on. You gonna trim? Oh my goodness. Okay. This is Shira. So what's happening with our foods here? So all the cells in our body require food to function, whether it's to repair them, to make them do things, to give us energy, literally energy to like move our body, to think, all that stuff. Our cells need stuff. They need different nutrients. They need different macronutrients. They need different micronutrients. So our bloodstream is the highway dropping that all off to wherever they need to go. So now I'm going to get more nuanced with the different types of nutrients and where they're going and how they're being used, stored, etc. So first we go where there's immediate need. And I'm going to now break this down into our 3 macronutrients: carbs, fats, and proteins. So with carbohydrates, they are going to be the most different in this process. So again, we first drop them off wherever we immediately need energy from our carbohydrates. Carbohydrates are our primary energy source. They are what we are running on all day long. They're what makes our body move. They're, a big part of our skeletal muscle. So we think about like exercise, that's primarily coming from carbohydrate. When we think of just like, puttering around the house, a lot of that's coming from both carbohydrate and fat stores. And our brain runs on carbohydrates. We need the equivalent of like 8 slices of bread a day just to make our brain function on a normal basis. And I think if you're thinking a lot, if you're using your brain a lot more than the average person, you probably need even more carbohydrate just to make your brain work. Okay. So what happens next? So I know the question a lot of people give is like, so how do we gain and store body fat or adipose tissue? So I'm going to get into how that works and all of this and why it's not as simple as you think. And it's not just calories in versus calories out. So if they're carbohydrates, once we've exhausted kind of all of the immediate need of where the food is going, and also in this discussion, it's based on, so we just ate a meal or we just ate something. As soon as our body starts digesting this, this is kind of where I'm basing this off of. So we ate something, our body has digested it, gets into the bloodstream. Based on the amount of carbohydrate that we've just eaten, we have our immediate needs that get met. And then if we have more carbohydrate than that, we're going to go to our second step, which is short-term storage called glycogen. Glycogen is in the liver and skeletal muscles, and it is our short storage form of carbohydrates. So basically, carbohydrates create these branched chain molecules that are very easy for our body to break one off and send it to be used where it needs to go. So when we're in between meals, we're trying to primarily run on glycogen. That's what our body loves to do. It's like, okay, we can't, we're not cows, we're not grazing 24/7. We need to be able to run on stuff in between eating occasions. Our body loves glycogen. Downside is we have kind of a cap on how much glycogen we can have at any given time. It has kind of a max storage capacity, which research has shown for the average adult is somewhere around 1,500 calories worth of glycogen storage. So then if we've topped off our glycogen storage, so we had our immediate needs met with their carbohydrates, we've hit our max level of glycogen capacity, and we still have some more carbohydrate floating around, then it's going to get stored as body fat. So it's not like, and I think the big fear factor with a lot of the fad diets out there right now is they're like, oh, carbs just get stored as fat. No, like they have to go through all of these processes before we get to our body even thinking about storing it as fat, because it is not efficient for our body to create body fat. It's not efficient for our body to break down body fat for energy use. Our body doesn't like to do it. We want to immediately use stuff, and we want to have this short form storage because it is just more efficient. Our body prefers this. So in this scenario, and what I'm going to talk about with carbs or with fats and proteins as well, is it's really based on how much food you're eating at a given time as to how much body fat you're storing. And I'll explain that further in just a minute. So that's the process of carbohydrate storage. So now with fats and proteins, I'm going to kind of lump them together because for the purpose of this explanation, they kind of do the same thing. So again, we're in the small intestine, the fats and proteins also in their single molecule form get absorbed into our bloodstream, get dropped off at the cells where they're immediately needed. I'm not going to go into all the purposes of fats and proteins right now. That could be a whole nother several hours of lecture of all the different things they do in our body. But just know that just like carbohydrates, we have immediate needs where they're going to get dropped off at those cells to go do their job. And then these don't have that short-term storage. So any excess protein and fat is going to get stored as body fat. Okay, so this also leads us to kind of the breakdown of some of our fad diets of why are Americans so obsessed with eating so much protein? Because if our body can only utilize so much at any given time, anything extra is going to get stored as fat, and fat can only be used for energy. It can't be used as like protein or fat to repair muscle tissue, to create hormones, like all that kind of stuff. So it really behooves us to actually consume more carbohydrate. And the recommended dietary allowance for carbohydrate is 45 to 60 or 65% of our daily calorie intake. So the majority of our diet should be coming from carbohydrate anyway. And on the higher end of that for endurance athletes, the lower end of that for diabetics. So consult with your individual dietitian for what your needs are. So yeah, so that's kind of how we use and store the three macronutrients. So I also want to end with an example here of, again, how body fat tends to get accumulated more and why I believe intermittent fasting is a really bad idea. So as we just discussed, our food is going to get used right away. Our body is going to put these things towards immediate needs. And if there's extra, that's when it gets stored as fat. So if we look at that, it really behooves us in more ways than just fat gain, but I know that's probably what you care about. But really in terms of health and how our body functions, to eat throughout the day. So the reason we have meals and snacks is because our body really does function well when we're having kind of a consistent trickle of nutrients coming in, because then we're able to constantly be replenishing the cells that need the things, and we're going to store less as fat. So the example I love to give is if you have a person, so same person, 2 different days. And on each of those days, they're going to eat the exact same foods. So the exact same type of food, amount of food, everything about it exactly the same. On one day, the person is going to eat all of that food evenly spaced out, macronutrient distributed throughout meals and snacks throughout their waking hours. And on the other day, that person's going to eat that same exact food, everything about it, the same amounts, all of that within, say, a 2-hour window of time. The day that they're eating all of that food in that short window of time, they're going to gain more body fat. They're going to store more body fat than the day that they had all of the food evenly spaced out, regardless of how much food it is. Okay? Because again, we either use things immediately or they're getting stored. So I hope this is helpful in explaining why dietitians are always pushing that we want you to eat multiple meals and snacks. It is literally for your health. It is so your cells can all do what they want, do the things they need to do so that they're just humming along and doing their best work. And it behooves the, part of us that doesn't want to gain excess body fat. So I hope this was helpful in explaining all of that, and let me know if there's other topics that you need broken down.